Okay, I guess it's time. It's a pleasure being here, folks. I'm Rahul Jadhav, one of the co-founders for AccuKnox and the CTO. I look after the product and engineering side. And more importantly, I'm also a security chair for Nephio, which is, I'm not sure how many of you know Nephio. Nephio is a elephant project. It's a graduated elephant project, which essentially does large-scale telco automation. Okay. And SPIFFE stands for Secure Production Identity Framework for Everyone. Let me just get this clear. It's a mouthful, I understand that. But basically, what it was able to achieve is to ensure that the workload identity, which is almost every organization has to deal with it, however small or big it is. And if you don't have that, if you don't get the workload identity correct, going on a security journey is almost meaningless in my opinion. Okay, so this is, I'm going to talk about what was the Nephio's rationale as to thinking from why does it need workload identity in the first place, and why did we select SPIFFE as the basis for workload identity. In most cases, I'm by myself a security vendor. We have a security product of our own, and we look after issues that customers complain about. Their accounts have got compromised. In most cases, what has happened is, in most cases, the attackers have actually logged in rather than hacked in. Right? And that's one of the, and why that happens is because most of the credentials are out there, kept in some shape or form in some repository or an image or a ISC code or somewhere, which then eventually gets compromised and that gets leaked. So identity and entitlements is essentially, it cuts across everything. It cuts across any resource that you access within your organization. It cuts across everything. And typically, there are two ways to think about it, right? Like user identity and workload identity. User identity, almost, it's such a mature domain that you almost expect it to be present in every case, in every context, right? Like you have MFA. The primary distinction between user identity versus workload identity, and also it is called as non-human identity. That's the term that Gartner recently started making use of. The primary differentiation is that you have a user who can actually attest to being the user that he or she claims to be. In the context of workload identity, that is very difficult to maintain or manage. Who's that? What is that entity who's going to attest to the identity, right? That makes it difficult to achieve. But then most of the people, when I talk about this, most of the people say, but what about access tokens? It's not like the first time we are making use of machine identities or application or service identity or workload identity. It's not the first time that we are doing that. Bad time to get a call. Sorry about that. Access tokens have already been there, right? Like we've been using, there's no organization there. I'm pretty sure everyone here must have used access tokens in some shape or form. Be it GitHub's personal access tokens, Google service account tokens, AWS secret ID and keys, infamous, yeah, there are a lot of dad jokes on it, but anyways, I'll keep that for some other day. Access tokens are widely used for machine-to-machine communication, and it basically allows the workload, it allows access to the workload if a client can produce an access token, right? Like basically that's the fundamental premise of it. But what are the problems with access tokens? One of the problems that I've already mentioned, right? Like, you have to use the access token. Basically, simply a possession of a token implies access. It's a risky thing to do, which means that you have to safeguard it becomes a secure credential at some point in time, right? And it makes it difficult to manage. It's very difficult to manage the life cycle of a token. How many times you might have used a token and forgot where it has been used? So tomorrow you go back and say, hey, if I have to delete this token, you don't know how long you've been keeping it, what all different applications or services might be using it. There's no way to track where all the tokens is getting used. It's impossible almost. Permissions change requires new token to be created. That's another big problem. You have a token, and then tomorrow you have to use, you have to change the permission on a given token, you have to change the token itself. And then you have to remember which all applications would need this particular change in permissions. It's extremely difficult to manage. Rotation complexities. It comes with the fact that it's difficult to find out where the tokens are getting used. So the rotation also is kind of difficult. And the byproduct of this is, in most cases, these access tokens end up having long-lived lives. These are long-lived keys, which are very difficult to then, that increases the attack surface, right? Like if, you have people moving out of an organization, they end up having the keys, and it's risky to have those kind of thing. Contextual access is not possible. Like a lot of times, what happens is that you want to allow access to a particular workload from a particular region. You can't do that with access keys. It's access tokens, and can easily go out of hand. If you have dozen of microservices and you want to implement something called as a least permissive boundaries, right? Like least permissive application settings, you have to have a mesh of service account tokens or access tokens. Each service talking to each other service, it quickly goes out of hand. It's extremely difficult. The point being, it's extremely difficult to actually take care of access tokens. And by the way, this has resulted, this has grown into a billion-dollar business now. And don't get me wrong, we are part of it. I'm part of it. We are benefiting from it as a security vendor. But fundamentally, when I look at this problem, the problem is different. When people talk about, hey, my account got compromised, my secret key and access ID, I don't know at which point did it got compromised, but here we are. So there are all sorts of security solutions that are sprouting up, which do secret scanning in code repositories, do secret scanning in container images, infrastructure as code repositories. You have secret scanners in now Kubernetes config maps, everywhere, right? S3 buckets, Google storage, you have it everywhere. Almost everything, everyone wants to scan and then push it into some sort of artifact. So basically, it's a byproduct. Like you see this as a problem. This is a systemic issue that we have created ourselves. What is workload identity? And the fundamental of workload identity is this. There is an identity provisioner which is located somewhere else. A workload will request for an identity from the identity provisioner. The most important thing, if you ask me, when it comes to this automated workload identity is the step of attestation. The attestation is a separate control plane signaling which happens to check, hey, whether this workload, which is attesting on behalf, using certain attributes, is actually the one which it claims to be. That's the process of attestation. And once the attestation is done, it's identified that the workload is the right workload, then the identity provisioner is free to then provision an identity. Fundamentally, that's basically the point here. Then at some point in time, once the data plane connection is established, there is a policy enforcement point. PEP, the term is used, this is a NIST term, policy enforcement point, at which point you can check whether the workload is allowed access using the JOT token or X509's credentials. The whole point of an identity provisioner in this case is to ensure that this X509 certificate or a JOT token is then provisioned at that particular workload, which can then be further made use of in the data plane connections. So that fundamentally changes things. Now you don't have to have access tokens. Now you can say, hey, this workload, and the workload identifies itself, right? Like, does this workload have access to these set of resources? Tomorrow, if a permission changes, you have to change the permission changes and the corresponding roles. But you don't have to necessarily deal with the access tokens. Fundamentally, that's what changes in this context. People usually ask me, hey, but we've been using Kubernetes based deployments, and we ourselves are using it. Doesn't that solve the problem inherently? Like, you have service accounts that are getting rotated, right? Like on a periodic basis. In fact, I think it's Kubernetes version 1.26 or 1.27 brought in a change which requires that the service account is rotated automatically under the hood. The primary problem with Kubernetes in general is that the scope is at the cluster level. And in a lot of cases, these applications are working across, the scope is not within the cluster itself. That makes it difficult for the service account to be used inherently. This was one of the reasons why Nephio couldn't make use of this mechanism, why, even though today there is dependency on Kubernetes service accounts to do this kind of workload identity. And it's not just SPIFFE. Every cloud service provider, CSP, has some sort of strategy in the context of workload identity. And the first one being, Google workload identity. You can search for Microsoft Entra workload identity, AWS workload identity. All these CSPs, this on the OpenShift side of things as well, there is a similar initiative. The good news is that OpenShift is planning to use SPIFFE itself. the primary point here is that you get a token, but the token is then reissued by the cloud service provider, and that basically has the access required for the resources itself. So long story short, the point that I wanted to bring through this slide is that almost every CSP has been thinking in that direction for quite some time. In some cases, Google Workload Identity itself was kind of, I think it was in beta for a couple of years, and that it moved into production like last year itself. These are not very old concepts, in the sense. Now, what is SPIFFE? Let me see if I can get the full form again. Secure Production Identity Framework for Everyone. Yeah, it's a CNCF graduated project. It is not that popular as you would assume it to be. If you look at in terms of stars and forks, but it's also a very niche problem. That reminds me that you should not necessarily go by the number of stars for a Git repo. The graduation criteria might be something else. The number of users for SPIFFE are much more higher and much more niche than anyone else, in my opinion. It covers primarily what it does is SPIFFE is a set of standards. It's not an implementation. It's a set of standards which says that you have a SPIFFE ID, which is essentially an URL which starts with SPIFFE : just like you have an HTTP URL which starts with HTTP : that's called the SPIFFE ID. And then there is a SVID. SVID is SPIFFE Verifiable Identity Document. It's essentially it could essentially be either an X509 certificate or a JOT token. The aim is to get that SVID. The workload's aim is to claim that SVID and get it locally, so that then it can be further made use of in the context of data plane communication. And then there is SPIFFE Workload API. So they have also standardized on a set of APIs, so that if there is any other implementation that comes in, they need to follow this set of APIs itself. And the Spire is actually a SPIFFE runtime implementation or reference implementation for SPIFFE. Most popular one out there, but there are other where I know of one other organization who has implemented their own implementation of SPIFFE. But basically, SPIFFE, Spire is a reference implementation. It's a toolchain of APIs for establishing trust based on SPIFFE. And most important thing, if you ask me what Spire does is, it gives you a set of attestation plugins. That's very difficult to implement, folks, because you have AWS, you have GCP, you have Azure, you have Kubernetes, as these are the different providers of your infrastructure. And you need a set of attestation plugins. I talked about workload identity and its dependency on the attestation procedures. You need to have these plugins in place out of the box, and Spire does that basically for you. And there are organizations such as Bloomberg where we have extended it beyond, wherein you can make use of HSMs for attestation purpose. What I'm trying to say is that the attestation plugins are getting expanded. They're maturing as the time passes, and it's mature enough that a lot of organizations are using this in their production environment. A lot of organizations. Now, the high-level SPIFFE workflow is, there are three aspects to the workflow itself. Registration. At some point in time, you need to tell the SPIFFE or the Spire server that you can expect these workloads to show up with these set of attributes. And if they show up with this set of attributes, assign this identity. But hey, before you assign this identity, make sure that you attest their claims. That's where the registration comes into play. The second is the attestation procedure itself, which I've already told, right? Like when the workload starts up, the first thing that it needs to do before it starts any other communication or network, it can start making use of any other network primitives, is to do this attestation, and then the provisioning and the updates, subsequent updates. You have to, any token, any credential has a life cycle of its own. It has to be rotated on a periodic basis. SPIFFE credentials are no different, but the most important thing is that the SPIFFE, as part of its control plane API, takes care of the rotation itself. So you don't have to worry about rotation by itself. The other important thing is that since you don't have to worry about rotation, you can keep a much lesser life cycle time, the expiry time for these tokens. In the implementation that we use in-house, we keep it 4 hours. It would have been impossible to handle that kind of token expiry if you would be doing it manually. Impossible. But because SPIFFE or Spire implementation manages the life cycle, we could keep it for 4 hours, which means that even if a particular credential gets compromised, we don't have to worry about it. We don't have to have a revocation mechanism in place. Typically with X509 certificate, that you have this difficult life cycle to manage. If a certificate gets compromised, you have to make sure that revocation happens at the right time. Yeah, so here what you see is, this is the Spire server. There is a registration of workload and attestation, cursor is visible. Registration of workload and attestation attributes happens here. The second is, you see the Spire agent here. There is a client workload and the server workload. Both of them are attesting. There is a Spire agent here, which is co-located along with the application. The multiple deployment models here, folks, it's not necessary that the application itself has to change so as to make use of something like this. But there are multiple deployment models. The Spire agent in the context of the Kubernetes deployment is the daemon set. For every node, you get a single Spire agent. And then this Spire agent is in charge of actually doing the attestation on behalf of the workload and saying that, yes, this workload is part of this particular namespace, this particular service account. It basically attests to the claims that the workload is trying to make. And then once it gets the X509 certificate, it keeps it at a predetermined location, and then the application continues working from there. As simple as that. You might not necessarily have to change the application flow. Your application is already using TLS, or might be using TLS, but it has to use TLS using a certificate, and that certificate location is something that, provisioning is something that Spire handles. And then once it gets the X509 certificate, the next TLS or MTLS connection that happens, MTLS stands for mutual TLS. It's based the client and server, they both authenticate with each other. And that's the model that one should typically use in a machine-to-machine communication. This authenticated connection makes use of the X509 certificates or the JOT tokens that are provisioned in there. Now, at this point, I need to bring in Nephio because Nephio is the solution that I'm here to talk about. It delivers carrier-grade, open, and Kubernetes-based cloud-native intent. So it's very opinionated. It's saying that we'll only use Kubernetes for large-scale automation. We have decided to make use of Kubernetes as the framework for large-scale automation. And the problem is that Nephio solves, it solves the problem at scale. We expect the telcos to deploy thousands and thousands of edge sites and regional sites. And those regional sites and edge sites, there are two problems with it. It's impossible to do any of this manual provisioning at this scale. And the second is, the impact of something going wrong is huge. So you have to have automation in place. You can't do manual provisioning. So Nephio is something that aims. This is a project started by Google, but right now is part of Linux Foundation. I'll talk more at the end of the slides. You see, this is the high-level architecture for Nephio. If you see, there's a common layer here below. So you'll see different types of 5G workloads or telco workloads typically put in place, and there is a corresponding Kubernetes operator which manages the life cycle of that particular workload in a given deployment. That handles the automation part here. So everything from spawning up the Kubernetes clusters, deploying the workloads, managing the resources on those workloads, managing different resources, all of that is completely automated. There are certain founding boxes, foundational layers that Nephio makes use of. I need to talk about that at some level of detail, but it's important to understand that Nephio, the aim is that Kubernetes has been made use of, Kubernetes resource model has been made use of to do this large-scale automation. Now, why is SPIFFE relevant to Nephio? If you look at the evolution of telco deployments, we used to have SS7-based deployment. Then we had SIGTRAN, which basically allowed us to use SS7 protocol on top of IP. Then we had NGN and next generation intelligent networks. And then we now are moving towards cloud native model, right? Like completely cloud native model where operators today are moving towards deploying not just the core, like the 5G core, but even the RAN part, radio access network, part of the radio access network, so to speak, on cloud native models. I know of one popular operator, Dish Networks, who is doing that actively. their complete deployments, including the RAN, is on AWS EKS clusters, running on AWS EKS cluster. There are other operators following the suit, and I know it would be very difficult to compete with these operators because of the agility that they'll bring in. Very soon, everyone else will have to emulate this model, because otherwise they won't be able to compete. At this, the reason why a strong identity layers becomes a foundational concern for any service-centric operators. You have a bunch of workloads, a bunch of services that are offered on top of these on these networks, and you need to have a strong strong identity layer for the service-centric operators. And our job, as part of the Nephio community, is to make sure that we have the right building blocks under the hood to make sure that this can be achieved. Now, when it comes to Nephio's identity requirements, there were two high-level parts that we had to talk about. One is the Nephio's internal requirement, right? Like the framework-based requirement, the control plane-based requirement, and then there are workloads that are deployed on top of Nephio, which have their own set of identity requirements. So both of that have to be covered. And these are the, by the way, the detailed requirements document, the design, the architecture, all of this is part of Nephio 6 security wiki page. If anyone is interested, we'll look forward to having a detailed discussion. But when it comes to Nephio's framework requirement, internal framework requirement, there are multi-clusters. So Nephio internally uses multi-cluster orchestration. You have a core cluster, you have a management cluster, you have regional clusters, and you have edge clusters. You have to, it's multi-level hierarchy of clusters. And you have to manage all of those, and these clusters will be sending observability events back to the management cluster. How would they authorize or authenticate, right? Like they need to push the observability data at a particular point location. Would that be allowed? On what basis would it be allowed? How would that that authentication authorization happen? There's one small box that is mentioned here, Porch. Porch is one of the foundational building block for Nephio. It basically enables Nephio to do this large-scale automation. Porch stands for package orchestration. Again, there's a project called in CNCF called as KEPT, KPT, which does what the other templating engines also available, like Ansible and other things. But Porch or KEPT, what it does is it does this declarative framework of configuration. Like when you create a new cluster, that cluster has its own set of resources, and those resources have to be templatized. Typically, what happens is when you use Helm charts, you templatize that Helm chart with curly braces, and your values get substituted there. The problem is maintenance of those templatized Helm charts at after a particular level, it becomes extremely difficult. It becomes unmanageable. What KEPT does is it does in-place substitution. What it means is that you have a cluster with a specific values using which that cluster has to be created. It will do in-place replacement of those values and create a corresponding configuration for that particular cluster. And you can view it just like, so in case of Nephio, it does that in-place replacements, and then it pushes it to a Git repository. So if you have to look for that particular cluster's configuration, all you have to look at that particular Git repo, and then you'll exactly know what that cluster is going to actually deploy. Versus, if you have a Helm chart, you have to assume that, hey, this value would get substituted here. It becomes extremely difficult to manage. So that's what KEPT essentially does. Very simple concept. It's not that it's the first to do that, but it's first to do that in-place, replacement of values. That changes everything. It's a very small concept, but very powerful. So, and there are other requirements as well, right? Like most of this management cluster has certain control plane elements. Like there is a common vault, which needs to be provisioned access towards. The secrets needs to be provisioned access towards, and those have to be taken care of, orchestrated through a common mechanism. And that's where, again, identity plays a key role. You have to make sure that the authorization policies are in place, so authentication is a prerequisite for authorization. Nephio's telco or 5G requirements, there are many. I mean, as we talk more and more in Nephio community, we see that there are a lot more use cases that are coming up, especially on the SOMS side, on the ORAN side, inter-network function communication. The requirements are far too many, frankly speaking. The first requirement that we are targeting is is on the SMO side, where you have FOCOM who will use O2 IMS interfaces. I don't think we need to get into the details of O2 these aspects. The point being that there's multi-cluster communication. In fact, the new clusters are spawned dynamically. To do all this, you need a strong identity layer such that one can say, hey, I'm authorized to create a new cluster. I'm authorized to do these new, I'm authorized to access these resources on this new cluster. All of that requires an identity framework in place, and that's what essentially SPIFFE allows us to do. Again, this is quite a picture. There is a Linux Foundation article that we have published on the same. It gives you a detailed flow of how Nephio catalogs the whole Git flow works when provisioning this network, this workload identity. I would highly recommend. So I've mentioned 9 points here about what are the different steps that have to be taken for automatically creating the workload, the identity resources itself, and how the workloads at runtime makes use of these resources to actually claim the identity, and then do a data plane communication. All of this is synthesized in the document which is published on Linux Foundation wiki, as well as in their LinkedIn posts. I will definitely recommend you to go through that. But here, what you see here is, there is a catalog packages. That's a parent GitHub repository, which has all the catalogs of all the workloads as well as the control plane elements. Then you'll see Edge 01 and Edge 02. Essentially, what happens is that this is the actual Kubernetes cluster. This is the edge cluster, or a set of edge clusters. The aim here is to push. The Spire server is present here. The aim here is twofold. One, how would the workloads here receive the identity? That's one. And there are certain control plane elements here that needs to receive the identity. This particular flow makes sure that the resources, the Kubernetes resources that are required to provision this identity, are placed properly in the management repo, and the edge. For every cluster, there is a corresponding Git repo. These are some of the fundamental concepts that Nephio works upon, right? Like whenever there is it uses Git as a source of truth, nothing new. GitOps have been in place for so long, but it basically does automation at a different level altogether. So if something changes, that Git repo is updated, and then the corresponding changes are pushed. Config sync is again another open source, which basically makes sure that a particular Git repo, resources kept in a particular Git repo, are then synchronized with the corresponding Kubernetes cluster. That's a huge task. So even if someone tries to create a drift in the target environment, that gets reconciled over a period of time. So again, to do all these are important factors, because essentially under the hood, SPIFFE also leverages some of these aspects. So when the user says, hey, I'm trying to deploy this new workload needs to have this new identity, the whole flow has to go all the way to the edge clusters, and this is essentially the flow that achieves that. Identity federation is also another important point that typically, in most cases, SPIFFE is used because it allows such a flexible identity federation. It provides an OIDC provider of itself, but it gels well with most of the popular providers out there. Let me put it this way, that I do not see any single vendor providing all the infrastructure in the future for a given telecom operator. You will see a mix of them. Right, like today, Dish is using everything on top of AWS, but they definitely do not have plans to, to stick with just one vendor. No one wants to do that. No one wants to have a vendor lock-in. Identity federation, having a strong identity federation layer, plays a big role here, and SPIFFE is extremely good at it, because it does identity federation on all the well-known concept today. You have certificate chaining based on which the identity federation is based. And it's the right way to do it. To sum it up, telco deployments, most of these telco deployments are becoming more and more disaggregated. They're becoming more and more cloud. They're following more and more cloud native models. The more you disaggregate, the more there is a requirement to have the right authentication and authorization layers in place. You have a microservices model. We have seen what kind of demands it has already produced as compared to the monolithic deployments we used to have before. frameworks such as Nephio are enablers of such kind of shift, right? Like it's basically going to change the way in which we deploy workloads. So that's the operating at higher scales requires some foundational elements. And trust me, identity, if you don't get identity in place, you'll be playing catch up with all the security tooling out there. At some point in time, you're going to ask, on what basis are we going to allow this access? And that's where identity comes into play. Without having a good identity, which spans not only known this thing, it should span legacy workloads as well. So achieving that is a major challenge. I won't say SPIFFE will completely. It's not a single tool. It can't change everything overnight, but it's the right way to go because you don't have a vendor lock-in. You can use any workload identity provided by a cloud service provider, but at an organization level, if you can take a stand saying that hey, SPIFFE will be my genesis, the place where all the identity will be provisioned from, then it's a much better strategy in my opinion. That's basically sums up my talk. The reason why we started making use of SPIFFE in Nephio is that we expect multiple vendors to play their part in Nephio. We cannot have a CSP-specific workload identity solution in play. We had to have an workload identity solution in place because we already see secrets prowling happening within the community itself. So this was a prerogative that we had to work on. We started work on this in the release 3 of SPIFFE, which is just a year back from now. October 2023 is when the SIG security itself was formed as part of Nephio. That's when we started. We said we'll take care of two things. One was making sure that the OpenSSF score for Nephio itself is at par with the industry standards. And the second was the workload identity. If we get these foundational elements in place, we'll have a good, solid foundation. That's basically where all this work is started. I'm not saying that the work is finished, but we have now a good, solid understanding of the problem statement. Let me put it that way. Okay, the solutions, this is a proposed solution space. It's not upstreamed as yet. If you're interested, please let us know. We'll be happy to have this discussion in the SPIFFE working group, Nephio working groups. Thank you. That's all from my side. That's all I got. Any questions? Yeah. Yeah? Yeah.
So when you started?
There's a mic there, yeah, if you want to use. Excuse me? Okay.
So when you started, you referred the analogy saying that we have problem with access token,
Yeah.
use case of revocation. But SPIFFE is solving identity as the main problem, not as authorization as the main problem.
Yeah. So the question is, let me just repeat for the sake of maybe recordings, that I talked about access tokens. And access tokens, where is authorization and SPIFFE authentication coming into play, right? Like that's basically the question. Where is the relation here, right? That's what you're asking. Yeah, please, if you want to go.
No, I was saying like you referring the analogy of access token and revocation, but SPIFFE as a specification is mainly solving the identity problem as such. And
Correct.
Second thing is, in the diagram that you just showed, where you had one main cluster and then certain edge clusters. On all those edge clusters, why you didn't have any dedicated SPIFFE server as well, and just have one centralized cluster where every registration or whatever is getting? What was the idea behind of having only one and not at the edge locations as well?
So there are two questions here. Okay, so I'll start with the first one. Why? So I think at some point in time you yourself said it, because you said, why have a strong identity or authentication layer? Because a strong authentication layer then enables a strong authorization layer, right? Like that's why, and authorization is what we are doing when we use access tokens, right? Like we are saying that, hey, if you use this token, you are authorized to access this particular set of resources. So essentially, that's what the point of access token was. Like if you want to get rid of access tokens, if you have, and again, it's in some cases we can't solve it fully. Like the client as well as server has to support both of these things. So unless and until GitHub has support for something like this, you can't get rid of PATs or personal access tokens. But point being that if you have an identity-based solution, it enables strong authentication. Once you have a strong authentication layer, then based on that authentication, you can keep authorization rules somewhere. You don't have to worry about passing on the access tokens. That was the relation here. The second point you mentioned was why not have a dedicated Spire server for each cluster, right?
Edge location.
Yeah, and again, there is no, so in this case, why not have a dedicated Spire server for each of these edge clusters? All these models are possible, but eventually these Spire servers have to be then connected back as a nested Spire servers. But that model is allowed by Spire itself, or do federation between these servers. You have to have some connection, right? Like between. So this is the model that we have decided to go for the first version of Nephio.
Okay, it's a
Nephio.
First version only?
Yes.
Okay,
yes.
okay.
No, so basically, Nephio is
I correlated with the scale because you're saying it is for network and it is for ORAN setup and all those things. So it's like at a massive scale on the cloud. Okay,
yes.
In that term, so how come was it just one server? There might be some reason. That was my intention to ask the question.
So it's not like, this once, it's not a single server, like it's a Kubernetes deployment. Yeah. So it can scale, auto scale and all that, but it can handle hundreds of thousands. It's a control plane signaling at the end of the day. It's not happening, the edge servers are not sending thousands of messages per second. So this is an easily manageable deployment. Even if you have 100,000 edge clusters, it is manageable, is what I'm trying to say.
Next question, with not respect to with Nephio, but as such, your expertise or your involvement is there in Spire as well. So my question is, I see already a trend in the industry that people don't want to use workload identity issued from the cloud providers. As such, people are looking for unified workload identity framework as a mechanism. Red Hat is already trying to solve that because Red Hat is struggling with it because it has to allow supporting deployment on different platforms. So they are trying to build, a unified workload identity by trying to do federation with the actual cloud one. And then wherever cloud policy enforcement is coming, they are trying to use, SVID identities to basically identify the work. So is there any such thing that in the Spire or how cloud vendors are, looking at?
First thing what you said is absolutely true. No one wants to make use of a workload identity solution which is native to a particular cloud service provider. Once you do that, you're done. 100% sure that you are in there for a big vendor lock-in. So it's a major risk, and I know some of the work that Red Hat team is doing, and they're leveraging. I saw a recent article from Red Hat, which is basically talking about identity federation across different cloud service providers, but still making use of SPIFFE as the foundational identity layer. That's the model that I'm also in a way preaching here, because that's the model that with Nephio also we seem to be going in that direction.
So Red Hat is an individual partner, but anything that you see as a discussion in CNCF with?
Red Hat is we have folks from Red Hat in Nephio. We have folks from Red Hat, Ericsson, Google, Samsung in Nephio. I'm sorry if I've missed out names just by on record, but yeah, Red Hat is definitely a player in Nephio.
Yeah, you mentioned there is one organization which had their own implementation instead of using Spire. So I missed the name of that company. But why did they went ahead with that? Because what exactly is Spire missing that they had to implement?
Yeah, frankly speaking, I'm a little hazy on that as well. I heard it from someone else about that organization. Okay. I think the only reason why I could think of someone doing that is because the attestation plugins that they require might not be available readily in Spire. But then why not extend Spire itself for adding those attestation plugins is beyond my comprehension. But I know of one other organization. I can give you the name later, but I don't want to announce it here. Yeah?
Hello. Yeah. So I have two questions about this. So in your previous architecture, you have mentioned about SPIFFE as an agent, which will be there in the workload, right? So when we consider it as an agent, so will it communicate based on the network level? Like what kind of protocol will it follow if it is going to communicate behind the authorization method?
No, sorry. Can you please say it again, if you don't mind?
The Spire agent that you have mentioned.
Spire agent we have here.
I'm sorry. So the Spire agent which is communicating back forth to the Spire.
Yeah.
So what kind of networking protocol will it follow? And the question that I beg is like, if that communication fails, what will be the issue then?
Yeah. That's a good point that you brought up. So what is the root of trust here, and how do you bootstrap the trust here? when you begin in the first place. That's a very important topic. Yes, you have to bootstrap some sort of trust in the Spire server before you begin, but that has to be done as a pre-provisioning aspect, as part of the bootstrapping process. But this, you're asking about the protocol that has been made use of. It's not like Spire SPIFFE Spire is using its own protocols. It's using REST APIs.
Okay.
It's using TLS-based mechanism on this communication link as well.
Okay. So TLS as in the networking layer, like will it be 443, which is being used for communication? Okay.
Sorry, what? In the networking layer?
The TLS is mentioned, right?
Right.
Like, so which means like the 443 is being used
Yeah,
for the communication in the
443,
network
port
layer, right? So that's my question. So
Yeah, port 4. But eventually, right, like this is irrelevant. Like what kind of workload API has been made use of. Tomorrow, if someone decides to make use of some other protocol or gRPC for pulling in these credentials, the important point is that eventually X509 certificate has been pulled in as part of this handshake. And that X509 certificate can be made use of for MTLS, it could be made use of for IPsec, or it could be made use of for something else as well. It's basically a token that workload can then make use of for subsequent data plane communication. But yeah, today TLS has been made use of, HTTP-based or gRPC-based mechanisms have been made use of for this attestation identity provisioning. But that's a Spire-specific implementation.
okay. Okay, got it. Yeah.
Thank you. There's a question? Yeah, sorry, this and then after you. Is that okay? Yeah, please.
Yeah, so my question is regarding RAN. What RAN has to do with the cloud?
Yeah, so what happens is ORAN or Open RAN, as it is said, it has essentially what it does is it has disaggregated certain things. You have a radio unit, you have control unit and distribution unit as part of RAN. You can now push your distribution unit towards a cloud native model. Fundamentally, the problem is for any telecom operator that 60% of operational expenses are in managing these towers where you have these radio units and the RAN deployments that have happened there. And one of the biggest concern there is managing the cooling capacity and the whole execution capacity there. If you reduce the execution capacity, you automatically reduce the cooling requirements as well. You reduce the cost there. Like I said, 60% of the overall operational expenses are getting spent there. By disaggregation, what has happened is Open RAN has essentially allowed you to move some of the executional elements back to the cloud. And this is possible also in part because we now have a better networking, much better latency, backhaul. Let me see if I can put it in a different way. Much better links on which the latency is much better, is guaranteed, saying that you can achieve things in 10 milliseconds, for example. There are some hard requirements there. So if you are able to achieve that, then you can push your distribution unit in the cloud. So that's the reason why RAN is now getting split up, and some of the elements are getting pushed to the cloud native world.
So are telecom operators using RAN to test their infra?
So in every telco operator, the user equipments, the bunch of user equipments, our phones actually connect to the RAN, right? Like radio access network. That's the first point of communication. And then it goes to the core, and then eventually to the packet gateway and other backhaul networks.
Okay, got it. So packets from our phone to the cloud. Is it something like that?
Yeah, packets go, all our phones, we eventually connect to the towers, right? Like, and that's where, that's part of the radio access network.
Yeah, got it.
Yeah, and part of that radio access network is now getting shifted to cloud.
Got it.
The radio unit still needs to be, because there is a hard requirement of 1 millisecond, which is not achievable today. So there are certain things that have to be still there, along with the tower itself. Some processing has to be there.
So do these cell phone towers also use K8S?
No, not as of now. I mean, I'm not sure if anyone has ventured that far, but I don't know of any as of now.
Okay, thanks.
Thank you. Sir.
So the X519 certificate, which is getting generated, is it one time or it rotates after like some time?
Yeah, so the expiry of that X509 certificate is typically in few hours. Okay. So it has to be rotated. It has to be rotated, but it is rotated before the expiry is hit. So typically one of the decisions that one has to take into consideration for the expiry time is what are my SLAs? Like, if my device or if my edge cluster goes offline, you have to then make sure at that particular point in time when you might lose your connectivity. So if you lose it for more than 4 hours, then the attestation has to be done again. Otherwise, you can use the same TLS connection to get an updated certificate. It's not a big deal, but it basically, what it means that the attestation has to be performed, does not have to be performed all the time. Not sure if let me see if I can put this again in a different way. The certificate has a lower expiry time. The certificate, once it is about to be expired, like typically it is 1/3 or 1/2 of the time, the Spire will go for a updation, the certificate updation. It will do the certificate update. But what happens in some cases where your edge cluster itself goes offline for a duration which is bigger than the expiry time of your certificate, in which case the attestation has to be redone.
And this certificate gets generated on the basis of that workload or agent, on basis of what the certificates get generated?
That's a good question, and that's where attestation. For example, today the attestation plugins that we are making use of, those are actually Kubernetes service accounts and namespaces and Kubernetes specific attributes. So we say that, hey, if your workload is part of this, if your labels are these, then you are this workload, UPF workload, let's say for example. And then a corresponding identity is pushed. But now there is a control plane element which is attesting to all these factors and then doing the provisioning. That's the difference. We are still making use of certain Kubernetes native elements under the hood to actually do this attestation. It's not like completely, so it actually helps the Kubernetes native service accounts and namespaces and labels. These are the different attributes that are then made use of as part of attestation procedures.
Yeah, related question. So whether these certificates are generated by Spire itself, or it can work with a PKI?
No, it works with PKI. No, there is a CA that eventually generates the certificate. Yeah, so it's the same flow.
Does Cert Manager feature anywhere in this picture?
Oh, you can use Cert Manager as well along with Spire. So it's all the existing infrastructure of PKI has been made use of as it is.
Okay.
Yeah. So it's not that the Spire has its own implementation of Cert Manager.
Okay. Yeah.
Thank you. Thank you. Thank you very much, everyone. Thank you for your patience. Thank you.